Let's take a look at review problem 3.7. We have a shipment of fibers that is acceptable if the strength is 50 newtons, but it's not acceptable if the strength is less than 50 newtons. We test 80 fibers, and the mean breaking strength is found to be 49.1 newtons, with a standard deviation of 5.2. First, determine if the shipment is acceptable at the alpha equals 0.01 level of significance. We first recognize that this is a hypothesis testing question. This concerns an average. This is a one sample problem comparing the average strength to the posited average strength. It is a one-sided or one-tailed hypothesis test because the question is it less than 50 or not? It is a large sample. The sample is more than 40. And so for these reasons, the test statistic in question will be Z. The null hypothesis is going to be that the mean is equal to 50. If the mean comes out to be greater than 50, we certainly will not complain. And the alternative hypothesis is that the mean is less than 50. Okay, now to compute the test statistic Z for a one sample problem, we have that Z is equal to the observed average of 49.1 minus the expected average of 50 divided by the standard error for the average, which will be the standard deviation, divided by the square root of 80. Using, as always, our bootstrap substitution, the sample standard deviation for the population standard deviation because we have a large sample. Okay, this works out to be negative 1.548. From this point forward, there are two ways of proceeding. First, we can find the test statistic, the critical value. We already found the test statistic. The critical value is going to be the first percentile under the normal curve, so that the area in the left tail is equal to 1%. And that works out to be negative 2.3263. That's the critical value. The test statistic negative 1.5 falls over here someplace, and so our decision will be to fail to reject the null hypothesis. The second way of making a decision would be to find the probability of making a mistake this, or finding an event this extreme or more extreme, to find the p-value or the observed significance level. That means, practically speaking, to find the area to the left of negative 1.548 under the bell curve. And so using our technology, we find that the p-value is equal to 0.0608. And so that number is greater than our value of alpha, and so we fail to reject the null hypothesis. Or we can say that the test statistic is not in the rejection region, so we fail to reject the null hypothesis. So either way, our conclusion is that we fail to reject the null hypothesis. There is not enough evidence to suggest that the mean breaking strength is less than 50 newtons. And so that answers the first part of this question. The second part of the question concerns finding the power. Find the power of the test if the mean breaking strength is indeed 48 newtons. For this, we will use the formulas for beta that we found in the textbook, which we derived in class. Actually, this is the one that we derived in class using hypothesis testing for a single sample with a mean. But rather than re-deriving it, we will just simply use the formula that we derived in class, noting that we need the form of the alternative hypothesis where mu is less than something. So we had three choices for beta, and the one that we want for this one is going to be that beta is equal to 1 minus phi times of negative z alpha plus mu naught minus mu prime over sigma over square root of n. Now once again we don't know the value of sigma, but we will use the sample standard deviation to approximate that. So 1 minus phi. Z sub alpha is going to be positive 2.3263. So negative Z sub alpha will be the critical value, negative 2.3263, plus 50 over minus 48, divided by sigma, which we will estimate to be 5.2, over the square root of 80. And so this is equal to 1 minus phi of, and we do the arithmetic, we get 1.1138. Okay, so drawing the picture down here in the bottom left-hand corner, 1.1138 is over here someplace. Phi always means the area to the left under the bell curve, so 1 minus phi will be the area to the right. And so using the normal CDF command on a calculator, or else normsdist, we find that the area to the right is equal to 0.1327. Finally, the question asks for not beta, but the power. So the probability that we correctly reject the null hypothesis, if the null hypothesis is correct, the power is 1 minus beta, and so the power is equal to 1 minus beta, and that is equal to 1 minus 0.1327 for 0.8673. Finally, the third part of the question asks for the number of tests that are necessary if we want the probability of a type 2 error to be 0.01 if the mean breaking strength is 48 newtons. And you notice that a typo on the handout's been corrected in this video. So the formula for this, we have two formulas for the number of samples that are necessary. This is a one-tailed test, and so the formula goes n is equal to sigma times Z sub alpha plus Z sub beta over mu naught minus mu prime, whole thing squared. In our case, we estimate sigma to be equal to 5.2. Z sub alpha we've already determined to be equal to 2.3263. And remember that the z's are always positive numbers, though the critical value itself could be negative. Z sub beta is going to be the exact same thing because we're looking for the probability of a type 2 error to also be 0.01. So by coincidence, Z sub beta is equal to Z sub alpha because the sought-after value of beta is the same thing as the significance level alpha for this problem, divided by 50 minus 48, whole thing squared. And so doing the arithmetic, we get 146.33. And we will round that up to be safe to 147. And so we would need 147 tests as opposed to 80 tests so that the value of beta drops from 0.1327, which we had for 80 tests. If we increase to 147 tests, then the value of beta will drop to 0.01, or actually a little bit less than 0.01.